equal to 3 times 10 to the power minus 3 meter squared. Okay. So from here, therefore, so this is important value. Yes, sir. Say it again. Yeah, but the way I... Oh, you mean something is missing? No, over here, this is regarding my second moment of area, right? Yeah, because the centroid XX for the taken away part, the centroid is at the same position, right? So if you use the other method, as in you did not take anything out, then you have to do the A bracket global centroid minus individual centroid squared. Okay, for this case, you don't need. Does that make sense or no? So the general formula, I do apologize. I should not skip step. Oh, you all know that Ixx is equal to BD cubed over 12 plus by B times D capital Y bar minus small y bar squared. Yes or no? Right? But because the centroid for the rectangle and the small, or for the portion that we remove, the centroid are the same what? Position. That's why this is equal to what? 0. Are we clear? Wait, I need to look at you. Some of you look like a deer standing in front of my car before I knock you down. Okay, I get worried now. Okay, so, okay, I'm going to do a different technique for second moment of area that we have to apply the shift of the parallel axis theorem. Okay, I will show you. I want you all to be clear. If someone asks the question, let's sort it out first. Okay, I don't want to like rush and then we learn nothing. So another way to get this is I divide this into what? Into section. Yes. So I call this section 1, I call this section 2, and I call this section 3. It is still valid that this is still my depth. Okay. I would like to do section 2 first because section 2 is easier. Okay. So let's focus on section 2. So Ixx of section 2 is equal, so the width is 10, the depth is 100 cubed divided by 12. If I plus this, okay, so 10 multiplied by 100, the y bar over here is equal to 0 squared. This is because in section number 2, the XX line is exactly at its what? Centroid, yes or no? So when with, did I do this properly? With depth, wait, Ixx, wait. So Ixx, this is the width, and that's the depth. I think I'm okay, right? Yeah, I'm okay. So this will be equal to 100 or 10 times 100 power of 3 divided by 12. So it's equal to 833.333 times 10 to the power 3 millimeter 4. We know that Ixx1 is equal to Ixx3. So that will be equal. So the formula is Ixx, the general formula is equal to BD cubed over 12 plus by B times by D, big Y bar minus small y bar squared. Okay. So for this case, the width, so now we are looking at the left, at the right of the structure, the 1 and the 3. So the width is 10. The depth is 100 cubed over 12. The cross-sectional area is 10 multiplied by 100. Now the y bar is equal to 120 divided by 2 minus by 10 divided by 2 and the whole thing squared. Good. So this will be equal to 60 minus 5 squared times by 100 times 10 plus by 10 times by 100 power 3 divided by 12. So it's equal to 3. Wait, what do I get? 3.85 somehow, hold on. 60 minus 5 squared times by 100 times 10 plus by 10 times by 100 power 3 divided by 12 is equal to 3.85 times 10 to the power 6. Wait, did I do anything wrong? 120 divided by 2, 10, 20 divided, no, I did not do. So 120 divided by 2 minus 10 divided by 2. Maybe I pressed my calculator wrongly. Times by 10 times by 100 plus by 10 times by 100 power 3 divided by 12 is 3.858. Okay, so therefore Ixx will be equal to 83.333 times 10 to the power 3 plus by twice 3.858 times 10 to the power 6. The width. Go on. Wait, I might mix something up. Width, depth. Yeah, I found my mistake. Width, Eugene, come on, width. So width is 100, depth is 10. Am I right? Yeah, I'm like, Let me do it again. 120 minus 2 minus 10 divided by 2 squared. 120 divided by 2 minus 10 divided by 2 squared times by 10 times by 100 plus by 100 times by 10 power 3 divided by 12 is equal to 3.033 times 10 to the power 6 millimeter 4. So 3.033. So 3.033 power 6 times 2 plus by 3.333 power 3 is equal to 3.033 power 6 plus by 83. Eugene, come on. 833.333 power 3. And then if I 33.333 power 3 plus by 2, that's by 3.033 power 6. So I got 6.899 times 10 to the power 6 millimeter 4 or 6.899 times 10 to the power minus 6 meter 4. Is it the same? Yeah, yep, it's about the same. Okay, so both works. Okay. So from here, we can determine, did we determine our radius of gyration already? Not yet. So our radius of gyration Rx is equal to square root I over A. So this is equal to 6.9 times 10 to the power minus 6 divided by our cross-sectional area, which is equal to 3 times 10 to the power minus 3. So this will be equal to 6 power 9 power minus 6 divided by 3 power minus 3. So we get 6.9 power minus 6 divided by 3 power minus 3. Square root the whole thing is equal to 47 0.958 times 10 to the power minus 3 meters. So that is our radius of gyration. So going back to our formula, what do we know? We know everything. So we know our R now, okay? So what we don't know is our what? Do we know our R? We have to determine what is our P, okay? So we only know our R for now, okay? Let me copy the whole formula across so I will not be flipping pages. So we know our R, okay? So R is known. So next we have to find our PCR, okay? Our critical load, okay? So PCR, are we okay? Anyone have any question? Yes. So the width, so XX is our axis of interest. Any geometry that's parallel will be the width. Any one that's perpendicular will be the depth. Okay. I hope that answers your question. So next we have to determine our PCR, our critical load. So this is equal to pi squared E. And then we have to remember we are going to use our IXX over our equivalent length squared. Okay. Now this LE is together, okay? It's not L on its own, E on its own. So we know that this is pi squared. Second moment of Young's modulus is 200 times 10 to the power 9. IXX is 6.9 times 10 to the power minus 6. Our equivalent length is equal to what? So we have 0.7 multiplied by L. So 0.7 times 6, and then we're going to square. Okay, so this will be equal to shift pi squared times by 200 power 9 times by 6.9 power minus 6 divided by 0.7 divided by 6 divided by 0.7 divided by 6 is equal to 772.112 times 10 to the power 3 Newton. Okay, so we know our PCR. Next, our P. So P, I'm going to take this image over here. I'm going to copy. So our P, which is in the Z direction, right? Because this is our X and this is our Z. This will PZ will be equal to 130 times 10 to the power 3 plus by 50 times 10 to the power 3. This will be equal to 180 times 10 to the power 3. We no need to put minus sign. Why? Any idea? Why we don't need to have the minus sign? Because buckling is always in compression. Are we clear? So you can leave out on the minus sign. You don't need to put it. Right. So the next thing is we want to find C. Right. So we have P. We have P. We have PCR. Next, we are going to find C. So C is equal to what? So this is the distance for C. So C is the furthest distance away from the centroid about the what? About the x-axis. Okay, so that will be equal to 0.12 divided by 2. So this is equal to 0.06 meters. Yes. Yeah. Right, too many times. Thank you. Okay. 1 point. Thank you. So the last thing that we have to determine. Okay, so what we don't know, C, we know. So we don't know what is our what? What is our E? Okay, so the last thing that we're going to do is we're going to determine E. Okay, so E. Okay, so E is the eccentric distance. So for this case, we have what? We have two loads. Okay, we have two loads. So I do apologize. This is our Y. This is our rotation about X. Okay. Yes. Because C is the furthest distance away relative to the centroid. Why? Because the furthest distance away from the